Hello students, welcome to week 3. So in the previous week, we have covered mainly the macronutrients. We have talked about food composition and we have covered carbohydrates, lipids, and proteins. We also covered water, which is an essential part of food composition. Now we're going to go into micronutrients. So micronutrients are mainly divided into minerals and vitamins. In this first presentation, we're going to talk about salt. So the learning objectives for this presentation is to explain the chemistry of salt, to indicate the daily intake of salt, to distinguish the different types of salt, to discuss the labeling of salt for consumers, to describe salt extraction process, to compare salt contents in processed food. So let's take a minute and check where are our micronutrients located in the nutrition facts table. So in the nutrition facts table, we can see that here we have our micronutrients. Here is the same. So these are the mandatory macronutrients, and the mandatory macronutrients are vitamin D, calcium, iron, and potassium. So the only vitamin that is mandatory is vitamin D, and then we have 3 minerals, calcium, iron, and potassium. So these are mandatory. But in some cases, some foods have supplementation with vitamins or minerals. They have fortification, like for example, cereals. So they have other vitamins and minerals listed. And sometimes it's like a big list. So the important thing to notice when we are analyzing this is that we have for the mandatory, we have the amount. And here it's like in micrograms, calcium in milligrams, iron in milligrams, and potassium in milligrams. So this unit is very important. Sometimes we have some in micrograms, other in milligrams, and these are, as we have already talked about them, the daily values. So the daily values I have already posted in previous weeks fact sheets about the daily values. So each vitamin and mineral has specific daily values. These daily values are reviewed periodically, and then they are sometimes updated depending on the needs of the American population. For example, in previous labels or before this change in nutritional facts, the required vitamins were vitamin A and C. But now, because of studies, they have realized that Americans meet these requirements. So there's no longer the need to have them as mandatory vitamins. So now they changed to vitamin D, and this is mandatory, and vitamin A and C, they are not mandatory. They are, of course, required in our nutrition and so, but they're not mandatory in the nutrition facts. The only way that it will be required if you make like a claim. So if you make a claim about like high source of vitamin C or high in iron, then you have to declare it in the label. So here we have the daily values, and as I mentioned before, we have the fact sheets posted on campus. So vitamins and minerals are the micronutrients, and the only micronutrient that has this like special place, and it's like in bold fonts, and is here, is sodium. And we can see here sodium, and we also can find it here. So sodium is the only micronutrient, and which is has this like special spot, and it's in bold, and the others are, as I mentioned, in this bottom part. So sometimes we confuse salt and sodium. So salt is, according to FBA, what we call, and to this class, is sodium chloride. If we remember our classes in chemistry, we have seen like many salts. But for this class, salt will be sodium chloride, and we can also call it, or also known as table salt, and it belongs to the family of salts, right? So there's many other salts like potassium chloride, magnesium chloride, sodium sulfate. So there's many types of salts that I'm sure you have heard in previous chemistry classes, but for this case and in our food composition, that we are going to use salt as a synonym for sodium chloride. So and we're going to see in the next slide the chemistry, but the difference is that sodium just by itself is a mineral, and it's one of the elements of salt. And if you guys remember from your chemistry classes, sodium symbol is Na. So sodium chloride is equal to NaCl, which is the chemical formula. So sodium chloride and also, for example, potassium are electrolytes that are very important in our body. Sodium has a positive ion, and this is the formula, and it is called a cation because it's positive, and chloride has a negative, and that's why it's called an ion. So FDA defines salt as sodium chloride. So if a product label states no salt, there may be other salts, but no sodium chloride. So maybe we can have potassium chloride or other types of salts, but no sodium chloride. So here we have our sodium and our chloride, and when they combine, they form, they have both of them. Sodium has a positive charge, a +1, chloride a -1, and when they combine, they form sodium chloride. So what's the daily value? As I mentioned before, vitamins and minerals, they have daily values. These values are checked periodically, like every 5 or 10 years, they are reviewed and they may change. So it is estimated that Americans consume on average 3,400 milligrams of sodium, which is very high, and the daily value that is recommended is less than 2,300 milligrams per day. And this will be about 1 teaspoon of table salt. And there's like an ideal limit that it's not to consume more than 1,500 milligrams per day. So this daily value, this 2,300 milligrams, there was a change from the previous revision for nutritional guidelines. So before it was 2,400 milligrams, and now it decreased. So why are we so concerned about salt and daily value? So we are very concerned because salt in combination with, say, other components, like for example lipids, can lead to risk of health, heart health problems, obesity, diabetes. So salt is associated, high intakes of salt are associated with this type of diseases. So that's high pressure, as another example, hypertension, and that's why it's very important to keep our consumption of salt to the minimum that we can. But why we cannot avoid consuming salt? Because we need sodium, and sodium is so important because it has to do a lot of working water balance. It acts at a cellular level, so in our cells, to maintain the balance of water outside and inside the cell. So that's what we call like the equilibrium. And when there's not this equilibrium is not met, then there is transport of sodium ions across the cell. And it's also so important to blood pressure. That's what I was mentioning in the previous slide. High consumption of salt or sodium chloride is associated with high blood pressure and other health problems. Also, sodium is very important for nerve function as it helps in communication between nerve cells. So sodium is very important, as other vitamins and minerals. They have their specific functions in our body, but we have to keep an eye on the amount of salt that we consume and where this salt comes from and how to limit. So there's several types of salt, and we're going to go over like what they are. So we have here the kosher salt. So this type of salt, it has no additives and it has a coarse texture. Then we have the iodized salt. This is like the most common salt and is also referred to as table salt. It contains iodine and it's sourced from mines. Then we have pickling salt, which has no additives and it dissolves quickly in water and is used for canning or preserving. Then we have sea salt, and it's harvested from seawater, and normally it's used a lot like in barbecues, and so has also a coarse texture as compared to table salt, which is has a finer grain. Then continue with types of salt. We have flaky salt, which are very thin shavings, and this is used more for like garnishing top of sweet or savory dishes. This is the flaky salt. Then we have the smoked salt, and this salt has been processed with has been smoked with specific types of wood, like for example hickory wood. And then this is one of the most popular ones, which is Himalayan salt, which is salt that contains iron, and this iron gives this salt its pink hue, and it's sourced from mines in Pakistan. So one of the types of salt is iodized salt, and as we can see here from the image on the right. So why do we use iodine? So iodine is a trace mineral that is very important for our health, and we have to consume it through diet. And it's very important for thyroid health and hormone production. So having what we call, so as I mentioned before, we have a daily value that is set. And if we don't reach those daily values, or we will have what we call a deficiency. And normally in our diets, it's very difficult to have deficiency, but in some countries where there is hunger or malnourishment, we may have deficiencies. So having a deficiency of iodine can cause a lot of problems, like thyroid health problems. So that's why iodine is, or salt is, it's fortified with iodine. So iodine is added to all salt production, and it's required by law. So the daily value for iodine is 150 micrograms. So it's a small amount, but it's very, very important. And we can have some foods that naturally have iodine are eggs, dairy, and like seaweed and saltwater fish. And this type of what we call like a massive fortification is very important because this is not only done with iodine and salt, but for example, in some, cases, folic acid and tortillas. So folic acid is one of the B vitamins, and it's very important for women and pregnant women and child development or babies development before they are born. So the deficiency of folic acid can cause problems in the babies. So one of the strategies is to fortify tortillas, which are consumed by the population, and that's how we fortify tortillas. Other examples will be vitamin D and milk. Some vitamins, like vitamin in, not necessarily in the US, but maybe in other countries, some vitamins in pasta. Many of you selected for your term project cereals. So cereals have also a lot of vitamins and minerals, and we call these a fortification. So when we say fortification, is that we are adding a vitamin or a mineral that normally the food does not contain naturally. When we call supplementation, is that we are adding more of what the food already contains, but let's just leave it at fortification. So we're fortifying our salt with iodine to avoid health, thyroid, and hormone production problems. And this is done like everybody consumes salt, so this will guarantee that all the population is getting the iodine they need, and we will not have deficiency problems. So who is susceptible to iodine deficiency? Pregnant or nursing women, and also people that are in a vegan or vegetarian diet. And as I mentioned before, it's added to prevent what we call deficiency. It's iodine and salt is just an example, and it may impact the flavor slightly, but not to a degree where it is unbearable or anything like that. So where do we find salt? Well, salt is in a lot of places, but mainly the main sources are salt mines and sea water. So we call these rock salt, and the other one is sea salt. So I suggest, I'm going also to post these videos on Canvas. This is the production of sea salt and in Hawaii, and I would like you guys to watch these videos, and we call them salt ponds. The other video. Okay, so as I mentioned before, salt is so important in our health, but the excessive consumption of sodium chloride or salt is something that we have to keep in mind. So there's many claims for salt reduction, and these are the guidelines for this type of claims. This is just an example of claims. There's many other claims. We have claims for sugar reduction, fat reductions, saturated fat, cholesterol reduction, etc. And you can find all those in the FDA website. But here, let's take a closer look at and discover at salt. These are called nutrient claims or nutritional claims. So if we want to say something is salt or sodium free, we need to have less than 5 milligrams of sodium per serving. If we want to say very low sodium, 35 milligrams or less per serving, low sodium, 140 milligram or less per serving, reduced sodium, 25% less than the regular product. So here we are comparing, like for example, I don't know, a regular soup, and it has X amount, like say 100 milligrams of sodium chloride, and if we reduce it to 75, so we are reducing 75%, we can say reduced sodium. If we call it light in sodium or lightly salted, it is 50% less than the regular product, and no salt added or unsalted. No salt is being added during processing, but these products may not be salt or sodium free unless it is stated. So even if we don't add any salt during processing, the food may inherently contain salt. So let's take an example, and if I present you with these two images and I ask you what tastes saltier. So we have on our left Mission tortilla strips, and then we have on our right bagels, plain bagels. So if we just think about the flavor of these two products, I guess that most of you will say, well, these Mission tortillas are taste saltier than bagels. And normally this will be because salt is sprinkled on top of these tortillas, so we have like a contact between like our tongue and salt, so we feel that salty flavor or sensation. But if we want to really take a close look and compare these two products, let's look at here we have the serving sizes. So the serving size here is 28 grams, and that's 12 chips. And the serving size here of a bagel is 95 grams. So if we take our calculators and divide 95 divided by 28, we'll have a ratio of around 3.39. So now let's take a look at sodium. So here we have sodium, and we have 90 milligrams, and sodium 450 milligrams. So if we multiply these 90 milligrams times 3.39, we'll have here 305 milligrams. So if we want to compare them, if they had the same sodium content, we'll expect the bagels to have 305 milligrams. If we think or want them to have the same sodium content, like just making the conversions to have the same serving size in grams and then the same sodium content. And we are seeing that we have 450, so 100 milligrams more. So this is just if we compare the same serving size, we have more sodium in bagels. We don't perceive it as saltier, but it has more sodium. So sometimes sodium can be mixed, or salt can be mixed because of the ingredients, because of the process, and we don't feel it. We don't feel that it's saltier, but in reality it has more sodium, and that is what we have to read the label and consider these differences. So according to the FDA and what I have mentioned about health, and so it's estimated that about 40% of sodium consumed by Americans comes from the following: daily meat sandwiches, pizza, burritos and tacos, soups, savory snacks like chips, crackers, popcorn, poultry, pasta mixed dishes, burgers, egg dishes, and omelets. So it's very important to consider the diet we have, and also to read the label to be make sure that we are following the guidelines and that we are keeping our salt consumption to the daily value that is recommended, or less if possible. So these are some examples of websites where there's a lot of marketing toward the consumer to make them aware of sodium consumption and the diseases that are associated. Like, for example, we have heart disease and sodium, we have an interactive nutrition facts label for sodium, and we have the USDA MyPlate Be Salt Smart. So how our food choices influence our health, and we all know this, is very important, and these are the resources available for you guys to check. So what else can salt do for us? So salt is, we are in contact with salt daily. So for example, one of the uses of salt, which is a salt that is not for food consumption, but specific for this, is to melt ice and snow during the winter, depending on the part of the US where we live. And the salt is added on the roads to melt the snow and ice, and this is done because salt does something that we call the depression of the melting point, and this is what helps us melt snow and ice, the addition of salt. This is only true for temperatures that are 15 degrees Fahrenheit or minus 9 degrees Celsius and more. If we want to have or to do this at colder temperatures, we need to add other additives like magnesium chloride to have the freezing point lower and have the same effect. But then it's salt with other additives. that are mixed with salt to have this effect on, for example, roads. Another example is like in some type of sea where we have a high concentration of salt, and then you can float, and this is because of like the change of the salt has in the density of the water and salt, and the changes in density, which can make you float in this type of places. So if we know when we go like swimming, we can also float because of density, but also the addition of salt will make this difference or this capacity even larger, and that's why we cannot sink in this type of sea. So the questions for you are, guys, today are: what is the chemistry of salt? What are the types of salt we consume? Why is iodine used in salt? Where do we find salt? And what does sodium-free mean to the consumer? And the other nutritional claims also. So please feel free to reach out if you have any questions. And the next presentation we are going to have is going to talk about additives.